In this video, we'll talk about chemical families, the location of those families, and the properties. And so if you look at this periodic table, we have alkali metals, alkaline earth metals, transition metals, the boron group, the carbon group, the pnictogens with a PN, pnictogens, the chalcogens, halogens, and noble gases. Then down here, we have the lanthanides and the actinides. So first, alkali metals. Group 1A, highly reactive metals. They have one valence electron. They lose that valence electron to have a positive 1 charge. And they create salts when forming ionic bonds with nonmetal. Alkaline earth metals. Group 2A. These are also highly reactive, but they're not as reactive as alkali metals. They have two valence electrons, which means they lose those two electrons to become positive 2 charge. And again, they create salts when forming ionic bonds with nonmetals. The halogens, group 7A. Now they need a full valence shell to be stable just like every other atom, but since they have 7 out of 8 electrons in that valence shell, they'll gain one more electron, which means they have a negative 1 charge, and they form ionic bonds with metals. Now this is highly reactive because it has a high electronegativity, and like I said before, with the number of valence electrons, 7 out of 8, because it is so high, that's why you have such a high electronegativity. Noble gases, non-reactive at room temperature. They have a full valence shell, and because of that, that's the reason they're not reactive, because their shell is already full. When you run electricity or energy, fire through these atoms, they will become excited and emit different colors of light. That's like neon light. So the different colors of neon light are actually different colors of noble gases, or different types of noble gases. Each one emits a different color. Transition metals. These are very different than the alkali and alkaline earth, because not only can they display different oxidation states, so each element might have a different charge than one next to it or below it or above it, but each atom might have multiple different charges. Now they're less reactive than alkali or alkaline metals, and then you can form more than one possible unique compound with a given nonmetal. 6A, this is the chalcogens, 6 valence electrons, less reactive than halogens, and they can either accept or share electrons. 5A, the pnictogens, 5 valence electrons, very similar to the chalcogens, less reactive than halogens, accepts or shares electrons when bonding.